being said, also starting the live stream on YouTube. So if there is anyone interested for the meeting afterwards, I will send a link to everyone so you can share. I've seen that there is quite a lot of attendees. Great to see going up, and it would be great to know where you are based. So it will help us a bit to understand, like, this time where like how it where it worked the most, and also, like, yeah, feel free to write in chat all your location, and see how international it is. That being said, I let the floor to Clemens. All right.
Thank you very much, Antonello. Lights off. All right. Let's see what we have here. Good morning, good day, good afternoon, good evening. I think it's almost everything when I take a look at what we have. Brussels, Dubai, Tokyo, Berlin. Unexpected. Right, nice. It's a very international group. I love that. All right. So as Antonello has said, we'll be having a tour of the Humanitec platform orchestrator and together with AI. Let's see what that means and how it plays out. I hope you're all having a good time and we're having some fun together. Yeah, so first of all, before we get all too giddy, let's talk a little bit about platform orchestration, what that even is, and where the different angles are, how that interrelates with AI, or how it could interrelate with AI, and what you're going to see today, because we only have 45 minutes. I want to have some time for question and answers. That naturally means I cannot attack all angles that would be possible, right? So first of all, platform orchestration, what is that, right? An orchestrator is a very general term, but a platform orchestrator is something quite specific. So a platform orchestrator is a thing that actually provisions infrastructure and also deploys applications. So it knows about both domains and can, due to that knowledge and the capabilities to motivate both things, actually create consistent outcomes that are provisioning infrastructure, taking the learned configuration, configuring the applications and deploying them as well, so that you get a consistent whole instead of something that is a piecemeal. So that is at the core what a platform orchestrator does. And it also obviously has a lot of different things as well, but that is depending on the platform orchestrator that you're looking at. So there's more than one. We're looking at the Humanitec one today. Yeah. So what is the specialty of our platform orchestrator? So while redesigning the way how you deploy, it also helps you to redesign how your customers, your developers interact with the platform. And developers here is quite a broad term, right? Because that could be actual software developers, that could be citizen developers who are most of the time more on the domain of data analysts or the business side who still want to do some stuff, yeah, but then hit quite fast the obstacle of, okay, now I have something, probably vibe coded that together. How do I even get that into at least a development environment so that all of my colleagues can look at it and we can actually use it? Yeah. Question many companies have today. So citizen developers, or you might even see completely different stakeholders who actually want to have some fun with the resources of the company as well. The newest ones on the block are my electronic friends, yeah, coding agents. And what the Humanitec platform orchestrator tries to do is redesign the interaction surface for all of those stakeholders, providing a consistent API, UI, and CLI that allows all of them to access the infrastructure and the resources of the company in a secure, standardized, and optimized way. Right. So that's what platform orchestration is about, and what our tooling is about. And when I talk about AI, so what do we have here? A lot of angles of attack, right? We are going to mainly take a look today at two kinds of actors. One being the developer or the electronical developer, the coding agent. Yeah, how would I, wearing my developer hat, try to actually self-serve infrastructure and deploy something? Yeah, that I have probably generated. Let's not live generate a complete application. We could do that, but I don't want to spend minutes on us looking at a spinner while a coding agent does that. Yeah, so we're going to take in a prepared example. And what we're also going to look at is how a platform engineer could actually use AI to facilitate quicker adoption of a new technology. Yeah. What we're not going to look at today are a few cases which hover for sure around the core of AI, but I do not have the time to actually facilitate them in this demo. Yeah. So if you're interested in that kind of stuff, Antonello is your man. Yeah. Because you can poke him right here in the demo or at any time of day and night, as it seems, because for him it's right in the middle of the night. Yeah. You can poke him and ask to have a meeting set up with us where we can talk about these kind of things or about your custom cases, your specific challenges, where we can actually take a shot at how we would provide a solution for that. So what am I talking about? Some of the core AI cases like, okay, how do I even make a model available to my developers? Yeah. So how do I train a model? How do I facilitate the availability of models? That not just being cloud provider based coding agents, but your own trained and owned models, which are running on your own infrastructure, which somehow needs to be made available and then also cut into slices to be made available to developers as well, right? We're not going to look at that kind of challenge today. Yeah, so it's going to be me, one of my friends. I think my good old friend Claude might be showing up today. Probably his buddy Codex as well. Yeah, we're going to take a step at some development and see how we can actually facilitate that in a much safer and nicer way with our orchestrator. So fire chat part of the session is over. Let's go right onto my desktop and without further ado, get to know the orchestrator a little bit more. And then we are also already off to the races to actually deploy some stuff and have some fun. Okay, give me 2 seconds. I'm a confessing desktop messy. Yeah, so I need to tidy up 1 or 2 things. One day I will learn to do this before a webinar, but today is not the day. Speaking of the devil, if you should have questions at any point in time, yeah, feel free to drop them in the chat. I will try to pick them up as we go. If I can fit them in. If not, I will answer them at the end. If you have something that can wait till the end, put it into the Q&A tool. Yeah. We will not miss any questions. We will just then answer them at the end. All right. So what are we looking at? Platform orchestrator architecture. I wanted to quickly acquaint you with a schematical look at what we are using. That here is the platform orchestrator, which is available in a SaaS or self-hosted mode. So depending on that, this box here is either on our premises or on your premises. And we have the runtime infrastructure, which is totally definitely your premises, yeah, which is owning those runners. And those runners are actually executing all of the code that is needed for deployments in Terraform or OpenTofu way. And they are asking for work from the orchestrator. And due to that, there is no live connection from our premises to your premises, even in the SaaS world, but you're actually opening the connection, and that provides a good security posture. For the platform engineers over here to configure the orchestrator with projects, which are like binders for environments where deployments are happening, which are being used by the developers in either their human or their CI/CD pipeline or their agent form, whoever it is, is deploying resource graphs that create active resources through those runners with the platform orchestrator. So now, having heard all of these words, without further ado, let's see the thing in action. And over here, you can see we are doing AWS today. Yeah, I've prepared an AWS infrastructure, but it is completely, possible to take any cloud provider. We have a great first deployment tutorial available that I'm using here as well. And from the change view, you can see I've done 3 things. Commented in AWS, commented in AWS, and there is Google and Azure, for example, as well. And I've commented in AWS. So if you want to try this out on your own later down the road, today, whenever, just do exactly that. Fire up our first deployment tutorial, and about 10.5 minutes later, if you're going against AWS, you will have the same demo environment as me. So now let's get started. I actually do want to deploy something, and for that I'm going to use HCTL. Why am I going to use HCTL? Because this is how I interface with the orchestrator without any intermediary like a CI/CD pipeline, and this is also what an agent would later use to interface directly with the orchestrator. So our HCTL, we have prepared the CJNE tutorial project, which hosts an AWS dev environment. I know that already. And just so you have seen the UI of the orchestrator for the first time, that's it. Here is my project, and here is my AWS dev environment, and nothing has been deployed here. Right? So let's deploy into this environment, and I have a feeling, oops, we're in the root folder, so under manifest, there is a manifest.yaml that we want to deploy. And I seem to be doing this lately a lot of the time. I forget to write deploy. Hey. So checking project environment exists. For last deployment, there's no previous state for deployment. So we want to deploy something, and the diff says we are not deploying anything. Wait a moment, what's happening here? We're going to do it anyway. That's going to be really fast. And the reason why we're doing it is because we want to know that everything is in working condition. So going back over here, I can see a successful deployment, although there are no active resources and we have no graph yet. And the reason for that is I wanted to test the infrastructure, and my manifest.yaml only includes an empty workloads array, which is deploy nothing. But I actually fired up this runner here, which is sitting here behind the runner's point, to take up the deployment job, execute Terraform providers, which are dynamically configured according to the context, to execute modules, in this case no module, of certain resource types. But nevertheless, the runner has picked up my request to deploy nothing, has actually deployed nothing, and reported back. So we have a successful deployment, and we know all infrastructure is up and working. So that is naturally not the most fun thing to do. So let's actually deploy something. So let's take manifest2.yaml. Now we're seeing a diff, generating the diff. We can see we want to actually add a demo app, and off to the races we are. That's going to be quite fast because I'm deploying to Kubernetes here. The orchestrator v2 that I'm using here is actually able to deploy to more environments than just Kubernetes, so to more runtime environments. It can do Kubernetes, it can do VMs. It can do serverless. Yeah. But as a first example and as the main example, I'm still going to use Kubernetes because that only takes 21 seconds. So we want to have some fun with coding agents. Yeah. Let's stay on the Kubernetes track for a bit because any other deployment would just take much more time, right? But promise I'll do some VMs for you later as well, just to prove the concept. Yeah. So if you're asking yourself, what is the big difference between V1 that we have built for quite some time when we switched to V2? The reason was to make more runtime environments easily available. And for that, we revamped the architecture and thus coined the new version of the orchestrator V2. Cheers. All right, so now I can reload and I can see what we did. So this here is a resource graph. I can see a route, so I should hopefully be able to access what I deployed here. I have a score workload, so workload, and I do have a Postgres database. All of that lives as promised in a K8s namespace. And that's the visualization of my architecture. My application architecture come to life basically because the orchestrator will first of all create this resource graph and then manifest it in reality. So dependencies flow from left to right and deployment flows from right to left. We need to have a namespace before we can deploy something into it, be that an application, a workload, a database, or create some configuration like a route, right? And all of that is modeled inside of the resource graph. We use this graph metaphor to not only make things visually available for quick assessment for people, but also to make this navigatable when building out infrastructure for platform engineers. Yeah? So through the graph, I can access all kinds of things which are inside of the graph. And because it's a graph, I have a clear language to target things. But we'll see that a little bit later down the road. Now you've seen the graphical representation. Let's take a look at what was actually deployed. So this is my manifest2.yaml. And I do have a container in here, which has this connection string here, which is built out of placeholders. And those placeholders actually allow me to quickly select one of the resources, which is part of this manifest, like this one here, db type Postgres, yeah, and ask for the username of it. And use that as configuration for my application. Because this is a variable and a variable becomes an env inside of the runtime of this container image here, which makes it or which enables my application to query the environment for the configuration, configure itself, and off to the races we are with a configured instance targeting the right database. Now, I do have this route here, but I do think I have made a terrible mistake. How could that happen? Because that is actually pointing to funny code. And I know, because I'm not allowed to cheat here, right? We're going to take a look at it. That funny code is not connected to the load balancer of the cluster I created. Yeah, that is probably going to be a lot of work to fix, right? AI to the rescue. And let's quickly use this script here to actually get a few links to my agents, Claude and Gemini Markdown files, which are parameters for them to know how they should behave. If that is interesting for you, we can take a dive at one of those. They are all pointing at the same Markdown file, which includes some general information, how I would like to converse with my agents, what they should do and what they probably shouldn't do. And then let's take Claude, and I'm starting Claude with my also with an alias that is ClaudeX. And X is for extra dangerous in this case because that thing starts in bypass permissions mode. And that is vitally important because I don't want to hurt cats, right? If I'm having 3, 4, 5 agents doing things for me, I can basically get back to them on the basis of 3 to 5 seconds. And when I ask them like, hey, I found something. Do you think I really should do this? And that allows me to do zero other work, which is, from my perspective, not how you should work with AI, right? You get from writing code to writing specification documents, and then you get from writing code to telling agents to please continue. And the only way to actually make them have a go at the problem is to turn the bypass permissions mode on for Claude, for example, and the other agents have their equivalent. So I can actually do other stuff in the meantime. When you do that, please put them into a sandbox. Yeah, like run them in a container, for example. So you have hard control over what parts of your system they can access, which hard drive they can format and which one not. Yeah, these kind of things. And do not trust the sandbox that the coding agent brings along on its own. It knows that much too well, so it can most probably quite easily escape it if you ask it hard enough to do so. Right, so what I'm also using is a tool called Whisper, which allows me to now not stumble and produce a ton of typos, but instead talk in natural language to my agent. And that's what I'm going to do. So you can follow my thoughts more easily. Yeah, I'm going to provide the thing with a ton of context that I probably normally wouldn't give it. It could figure that out on its own. But yeah, here we are. So let's do this. Hey, buddy, I have deployed an application through the Humanitec orchestrator V2. I want to do some changes because it is actually having the wrong host name. So could you please go ahead and look into the infra directory where you will find the Terraform context and can find out what the actual Kubernetes cluster is that we deployed to. Please use the AWS CLI to acquire the kubectl context so you can access the cluster. Take a look at the cluster. If the wrong hostname, funnycode.de, actually made it to the cluster. And if so, please change that live on the cluster so we can have a go at it. I think it would be good to take a look also at what the load balancer of the cluster is and put that one in there so we can actually access our application through the load balancer. No, I don't want hands-free mode. Okay, so off to the races we are. And as I said, I'm deliberately giving the thing a lot of context here. I've basically step by step walked it through what it should do. And I wonder who's going to win now, because I try to enforce best practices on my agents, which are encoded into my agents MD files. And I'm asking it to break best practices here. Also deliberately so. All right, so load balancer is here. I can copy that already. See if anything answers. Whoops, here we go. All done. And that is actually my demo app. Yeah. Okay. So that has worked. Great stuff, right? That feels so wrong. And the reason is I've done a few things that should never happen. So first of all, I've asked the AI agent to actually modify things on my cluster. In any modern, more controlled or more GitOps style even environment, that would be a big, big no-no. And it also feels horribly unsafe because I'm in an administrative context. That agent could do anything. which usually in SIE terms spells out in outage, right? At best. Outage would be bad, yeah. What would be even worse would be an agent, for example, to make something accessible, patching the security rules of S3 buckets and exposing all kinds of data to the World Wide Web, aka the guys who are wearing the black hats. Yeah, that would probably be quite horrible depending on what is in there. So all of that should never be happening, right? And the reason why the agent can do that is, first of all, I'm in an administrative session, and second of all, I'm making it deliberately do this. Now, let's switch gears a little bit, because if I am actually a developer, not a hybrid between platform engineer and developer, as I play to be right now, I would not even have administrative access. It could also be wild that I do not even have read access. I can't see anything, yeah, which would not be too uncommon. I just know I need to fix the problem, but I don't have any access. Now, if you think about it, that is actually quite easy, because we deployed the thing in the first place without needing any kind of access. Yeah, we self-served the database and infrastructure, deployed everything just with a command, and the permission scope of that was safeguarded by the orchestrator. And there was no way to hallucinate anything, for example, for this database, because I'm just asking for a database here, which is a clear abstracted interface, and nothing can go wrong here. So let's ask the agent to fix this in the right way this time. Okay, that was great, but horrible. It felt totally unsafe. Please do not ever do that again. Please take a look at my manifest2.yaml, which is actually how I deployed this. It is in the manifest folder. Yeah, so please fix the wrong host name inside of the manifest, and then deploy again to the cluster using the Humanitec orchestrator v2 with hcuddle. With Claude, that's nice. But I meant hcuddle or hctl. I need to definitely start saying hctl, because that whisper thing never understands me right when I say hcuddle. All right, now here we go. Now it's actually patched the manifest. I can see that's modified. Scrolling down here, I can see the modified host name in the manifest. And I can see a deployment to the environment, hctl command. So it has quickly instrumented the CLI. The CLI is actually, and its help is meant to be used and understood by agents. So that is most probably going to go straight ahead and quite quickly. Yeah, I didn't give enough context and tell it where the thing really was, but it figured that out quickly, that it's in the AWS dev environment, and off to the races we are. Switching over to the orchestrator, I can most probably, if I reload, see a deployment coming in. Coming in is good. It was already successful. Yeah. As you can see, the orchestrator is tracking the history for all deployments, yeah, which allows me to, not only see them if I want to, but also understand differences between them. I can diff them, and I can also roll back to a different point in time. Yeah, which means now that it's redeployed, but I can still reload this, and this is still going to work. Yeah, great stuff. Okay. And I can see failed to connect to the database, because the redeployment actually, depending on my configuration, redeployed the database as well. And that database server is going to take some time to come up again. All right, so now let's have some real fun. Switch over to the platform engineer side of things, and let's do something that I normally also wouldn't be doing, at least not without a hard review cycle. And all kinds of other things to actually align the outcome with the cross-cutting concerns of my company. Yeah, like security, compliancy, possibly even legal. All of them want to have a say at how, for example, a Redis cache is actually being defined and safeguarded in the context of my company. But we're going to quickly wipe platform engineer a solution for our application here. Who would love to have a Redis? Because you can see, yeah, counter result, no Redis client configured. Let's change that. Awesome. Now I want to add a Redis cache to my application. Please go to the GitHub repo of the deployed app, Astromecha, a demo app, and find out how the variable is named that you need to supply with the connection string of the Redis cache. You then also need to design a whole Redis module because we don't have one yet for the orchestrator v2. So please design a module. Do that in the infra folder in the Terraform code. But please keep in mind that we do not want to commit anything to a Git repo here. So please inline the HCL code for the module. You also need to provide a Redis resource type. And when you have actually run the Terraform apply, you can use that inside of the manifest2.yaml that you please modify to have the Redis cache included, the application configured to actually use it, and then deploy that through HCTL with the orchestrator v2. Right. So while this is cooking, I love it when people do things for me. We can do something else as promised, right? So let's start a new terminal and do something else on the sideline. I also promised that I would show you how things look if we're not deploying into a Kubernetes cluster. And for that, we're going to use Score as the interface. Score is a platform agnostic and workload agnostic, environment agnostic workload specification, which is hosted by the CNCF. All right, so CGNE tutorial. And as we're doing a Score deploy this time, we actually want to deploy to the AWS Score environment. And from the manifests folder, the score.yaml. Okay, so that looks exactly the same on the deployment path. And I think if I show you the difference, between what the Score YAML is here and what the Score workload looks like. Oh, sorry, that's on top here. Yeah, the Score workload looks like. That is basically exactly the same. Minus the database, I've left that out so it deploys a little bit quicker. Yeah. So we can leave that brewing in the background. On the sidelines, we're having our agent here inlining HCL for Redis modules. Looks good. Everybody's working. And everybody on the side of the webinar is silent. I've not seen a single question in the chat. But now would be a perfect time to actually answer one because I'm waiting on 2 terminals to carry out their work. Let's reload that. Oh, not yet. It's a race now. I think this is going to need about 3 to 4 minutes here. Let's see if the request to build myself a complete Redis solution out of nowhere is actually going to be faster. So while that is running, and I'm not seeing any questions come in, or I'm looking at the wrong stuff, possibly there is. There is a question in the Q&A thing. I totally didn't have that open. How to build governance into deployment pipelines. Like, I don't want to deploy in particular region, do not use particular instance types, etc. That is a very good question. And to answer that, we have to look a little bit more at how the orchestrator is actually using things. Let's do that while the thing is running. Perfect segue. Thank you very much. So we have resource types, right? Whenever I'm ordering something of a specific type. And that is like a contract between the developer and the platform. For example, a Postgres here delivers these properties here back to the developer. So he knows, okay, I can take those and construct a connection string. It also is a contract between me as a platform engineer and the platform, because if I create a module that creates a database, I know, okay, this is what I need to deliver back to the platform so it can use it. And that means when I take a look at the modules, let's say the in-cluster Postgres module here, then I can actually create the right thing. And the right thing is living under version control in Git here. Yeah, we could take a look at that if we wanted to. But for the moment, we are going to leave it at this. Is a very straightforward Terraform module to actually provision a Postgres container, right? I'm using some module inputs here to actually forward the name of the namespace into the deployment of that thing. Yeah, because this is an in-cluster database. It needs to know into which namespace I want to provision that database cluster. And as you can see, I'm not letting the developer build that up or make that up. I'm saying, okay, I do have a dependency on a namespace. And if there is none yet on the graph, then having that dependency will actually create one on the graph. And I'm passing in the name of that into the module. Using the same mechanisms, I can actually say, okay, this is what it's going to happen. Fully dynamic according to the context. So that is how you actually apply the hardest form of governance. You rule out that anything else happens, right? And then there is module params. In our case here, for the database, there are no accepted parameters. And parameters are what you have seen inside of the deployment manifest. For example, here the container, so which container image I'm deploying is a param. Yeah? And a param means me as a developer, I do have influence here. I can inject this parameter and by that influence how the actual module is going to handle or create the outcome. So for a platform engineer, it is very easy to actually influence what is the concrete outcome. Yeah. So now coming to this little tab here, rules, because you haven't seen that one yet. And that is one of the core traits of the platform orchestrator. So there's a rule set or a set of matching criteria I can apply, or I can apply more sets of matching criteria to each of my modules. And that means in this case here, everyone who's asking for the resource type Postgres, and there is no other limitation here, will get an instance which is facilitated by this module. Yeah. Now I could have rule sets which are more restrictive, matching closer, and because of that would take precedent in a different context. And you're going to see how that is applied when we take a look at what happened in the second terminal. But before we do, let's take a look at our outcome here, because the thing said, okay, I've done my job. Let's first of all take a look here and possibly reload this. And here we go. We do have a Postgres and we do have a Redis. All of that is in one namespace. Let's take a look. Yeah. And it's really easy to do that because I can simply go over here, reload that. And as you can see, Redis counter result 34. The more I reload, the more I increment this result. It will auto reload every 5 seconds. Because of that, we already had 30 on the counter, right? So yes, we created a Redis database. Yes, we connected that application to the Redis database, and that is up and running. Now, if you don't trust me, I could query into the cluster and show you that, but I rather use the time to show you how we actually deployed something else, like this score file here, which looks eerily the same and also answers some more of your questions, right? So just to close down this part here, as a platform engineer, I now have created a new resource type, yeah, which is available here now, Redis, which wasn't here before, an in-cluster Redis cache, and I've created a new module in cluster Redis. And taking a look at that, I can see that the module source is inline as asked for, and this is the actual HCL code, yeah, which literally creates a Kubernetes deployment. And yeah, with Redis 7 Alpine. This is the spec of the container, right? So that's what the orchestrator is doing here. Very much straightforward. Usually I would say that is a big no-no as well. That belongs under version control. But for this demo here, that's the quicker path to success. So to answer your question right away, Bharat, do we get Git link to see your code? Yes, you do. Not a Git link, but rather a link to our documentation, so to speak. I guess Antonella is going to paste that into the chat soon. He's nodding. He knows what's coming. This should be a link to our documentation, which is hosted under developer.humanitec.com. And in there, you have the first deployment tutorial. And that is actually everything I'm using here. And you will get a link to the Git of the fully terraformed environment that I'm using here. So you can replay all of those examples on your own and do not need to trust me in my saying. All right, so now what else did I want to show you? I wanted to show you what's happening here in the second terminal. That did run for exactly 4 minutes. Nice. And we would expect that to be quite the same thing, right? Because we deployed something that is looking eerily the same here on the YAML side. But if I go to this environment, you can see that I do still have a score workload, but that is now connected to a VM fleet. So what we did, and I probably should have, did I? I could have. Yes. Let's quickly hop over here into EC2. You can see that there are 3 fleet instances running here, T3 micros, not the biggest investment. And you can see they are now up for 9 minutes. Sorry for that being German. Why is it? No idea. But launch time 9 minutes ago. Yeah, so they are quite fresh. Nothing is cheated here. And if I go to the load balancers, I can't find the load balancer, the fleet ALB, which is in front of them. And I can show you by setting this to refresh equals 1, what I like to call disco demo mode. The background color is chosen randomly upon deployment, so you will see 3 different background colors here in a cycle. Although there are 3 shades of pink. What the? I didn't see that before happen. Usually it's something much more mind-boggling. Yeah. Okay, so 3 different shades of pink. Why not? So we deployed the same thing, and the orchestrator turned it into a Kubernetes deployment in one case and a very different thing in the other. And the reason for that is that behind the resource type of a score workload, there are 2 implementations. One is score K8s. You've seen that in the first one. But then we have my Ansible score workload, which is also a score workload. And that thing now has a dependency on the VM fleet. And that's why it appeared on the graph. And the rule set here says, if you're deploying to an environment with the ID AWS score, and we did, then this is actually, what is the minimum amount required to request a payout via PayPal? That is a very interesting question. I have no idea what you're talking about. ah. Right, so this is So this is what was used as a rule set to actually determine which module should be used for the specific context, because that is the calculated at deployment time. Me as a developer, I don't need to know that. I simply tell the orchestrator or the platform, hey, please deploy this application into this environment. And the orchestrator fully dynamically determines along the rules of the platform engineers, which represent the golden paths and all of the governance, which is actually there and available, yeah, what the right outcome is. In this case, it turned the same thing into a deployment on top of VMs. All right, so that is all that I wanted to show to you today in my whirlwind tour. Yeah. Yeah, I hope that was interesting. And now we can take a few more questions if you have some time and you have some questions, and then we'll close it down. So let me scroll back a little bit and see. What is the key differentiator compared to doing this through traditional CI/CD pipelines? Well, I hope, Vladimir, that was already pretty much clear. That the orchestrator is actually dynamically at deployment time determining according to the rule sets what's going to happen. If you try to build the same flexibility into a pipeline, then that's going to be really tricky. Yeah, because you will basically need a pipeline that is able to call other pipelines dynamically, which might be calling other pipelines dynamically. And that's going to be a maintenance nightmare. And doing that with a non-graph oriented system is just painful. Yeah. Also, pipelines do not provide this API-driven approach for agents to hook into. They do not provide the same abstraction level that the orchestrator allows you to have. They do not provide a self-service interface for agents, for developers. Yeah, so the orchestrator is quite a lot rolled into one box that is not covered with a CI/CD system, which just enables you to run workflows in the first place. I'm not going to say that you cannot do it at all with a CI/CD system. It's just going to be a very painful experience to build that. Yeah, that I would say is the main differentiator. So, does the Humanitec platform offer a way of creating building blocks which will include the use of Terraform providers modules, but in our enterprise environment may also include pre-post calls to different enterprise platforms? Lawrence, yes, it does, obviously. That is very much in the box. And also what I haven't shown you is that we make quite a bit of use of the standard Terraform workflow of plan, approve, apply, so to speak. Yeah. And the reason for that is simply that I do not have enough time in this demo. Yeah. We are running over even now just because I want to answer some more questions. Yeah? If you're interested in advanced use cases, just go to humanitec.com. Let me quickly do that for you and take a look at use cases. I have a feeling like in here in the use cases, there might be something in there that actually helps you to see how we do that. Yeah. Okay. Why we have used Humanitec compared to Backstage? What advantage we get as compared to Backstage? Well, very simple, Bharat. Backstage is a portal, which is a front end, which gives you a software catalog. But it doesn't give you any actionable buttons or any things that will run automatically. That is what the backend of a platform will do, and the orchestrator is a backend component of a platform. If you want to get more bang for your buck, so to speak, you combine a front end with a back end, as in most software architectures. Yeah. And through integrating them, you enable your front end to actually have buttons that do something when they get pushed. Yeah. So that is the main difference between the orchestrator, which is a backend and provides a clear API and interface layer to self-serve things inside of your platform, versus a portal, which does very different things. So, anything else? Did I miss any questions? Okay. I think I have caught everything I can make a reason of. Bharat, I don't know what to make of your questions. I think the best way to get answers to those is that you set up a meeting with Antonello and give us some more context on what you actually mean. Happy to answer them as soon as I can grasp under which context we are operating. And apart from that, I hope this was a meaningful session to you guys, although it was a whirlwind tour. I hope it was good info. Please do hook up a meeting with Antonello if you need to have any more specific scenarios answered, or you want to see something that is more relating to your context. I wish you all a wonderful day or night or whatever it is, wherever you are on the planet right now, and hope to see you around. Have a wonderful day. And back to you, Antonello.
Thanks, everyone. And as I put in chat, in case anyone want to reach out for more deep dive or anything, there is my email for anything. Thanks, everyone, for joining and to stay all the 45 minutes and 1 hour. Hope to see you at the next recording demo in a month. Have a great day, everyone.